So in today's video, we are going to look at what geometric sequences are, and I think we're mostly going to focus on this first target of finding terms of a geometric sequence. In the next video, we'll talk about writing recursive and explicit formulas, although we'll probably get to that at the beginning of, or at the end of this one. So right now, I want you to look at these two sequences and pause the video, and can you think about some things that are the similar and different? Write them down. So when I look at these, one thing that's similar that I can say is they start at 1. They both start at 1. Another similarity is they change by 2 in some way, in different ways, but they both change by 2. Another thing I could say is that they are infinite. They go on forever. It's not a finite sequence, it's an infinite sequence. So what's different? The green one, we change by adding 2 each time, right? I add 2 to get to 3, I add 2, and that's called then, that makes that an arithmetic sequence. In the purple one, I actually multiply by 2 each time, right? I say times 2, times 2, times 2, and that is what we call a geometric sequence. It's sort of like our exponential function. So if arithmetic is our linear function, exponential is our geometric function. So we can look at this problem right here. How is the number of squares changing? If you want to take a minute and take a look at that, what do you think? One good question I've had students ask is, when you talk about squares, do you mean the colored squares? Do you mean all the squares? And those are really good questions to think about. Well, when I see this, I'm talking about the colored squares. Let's look at that way. There's lots of ways you can look at this and counting. But if we are looking at colored squares, there's 1 right here. This one has 5. And this one has 5 groups of 5, which is 25. This one has 5 groups of those 25. 125, and so forth. And now we have 5 groups of the 125, which is 625. And so it is multiplying by 5 each time. So now we get to the definition part. A geometric sequence is that sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant, right? That fixed non-zero constant is the thing we call the common ratio. So in this sequence that we just created, our common ratio, it's basically what's this number that we're multiplying by every time. And so our common ratio here is 5. Okay, so now if I have some information, I can use my values and write out n many terms. So how many terms do I want to write out? I want to write out 4 terms, and I'm starting with the first term. So that a1 right here is 1/2. Now, actually, I like that better when I write it sort of this way. I think it's easier to see when you do fractions up and down this way. So now to find a2, I'm going to multiply by 4/5. And when you multiply fractions, remember, you multiply across the top. So 1 times 4 is 4. And then you multiply across the bottom. So we're going to have 4/10. The next term, again, we can multiply by 4/5. 4 times 4 is 16. And then 10 times 5 is 50. And if I want to get to a4, I'm going to multiply by 4 again on top. I get 64. And multiply by 5 again on the bottom, and I get 250. Now, if it is given to you in this form, I think it's fairly easy to see that common ratio. One thing to notice, though, is sometimes they can get tricky, and you can see, like, I have 1/2, but it can get, the 4/10 could be reduced. So we could turn this into 1/2, 4/10, each divides by 2 is 2/5, I can reduce my 16 over 50 and get, if I divide by 2, I think I get 8/25, etc. And I think I can divide the last one by 2, but you get the idea. This version would be much harder to find our common ratio, although really you just divide, and we could do that. Okay. So here's another slightly trickier. I want the first 5 terms, but they haven't given me the first term. My first number I have is A3. And then the next term after that is 125. I want the first 5 terms, so I need to go one more here, and I want to go back 2 terms, because this would be my A1, this would be my A2, this would be my A3, this would be my A4, and this would be my A5. So what I need is I need to find that common ratio. And to do that, I need to know, how do I go from 100 to 125? And so I'm going to take the next term in my sequence. So in this case, my R, my common ratio, is the next term divided by the term before. And I get 1.25. Right? And so that's how I move to the right, times 1.25. So if I want the next term after 125, I can take my 125 and multiply by 1.25. And I get 156.25. To go backwards, I'm going to take my 100 and I'm going to actually divide my 1.25, and I get 80. Because then if I multiply my way to the right, I will end up with 100. And then I'm going to take that number, and again, I'm going to divide by 1.25 again, because I'm going the opposite direction. And I get 64. Hopefully that makes sense. So I had 2 numbers in the middle. I could find the common ratio by figuring out what I multiplied by, right? Whenever you want to find your common ratio, you can take an, any term you want, and divide by the term before. It's any term. This is what R equals. Any term divided by the term before. And as long as that's always the same throughout my sequence, if I take a term and divide by the term before, I get the same number. That's what we call our common ratio. They have the same ratio of next to the one before. All right. So I think we're going to stop the video here, because next we're going to look at how do we get a formula for this. So we have an idea what a geometric sequence is, and now the next video we're going to talk about how do I get a formula for this.